In this video lecture, we're going to learn about the similarity of electronic configuration in a group. Now, in O levels, you've studied that in group 1, the outermost shell has 1 valence electrons. In group 2, the outermost shell has 2 valence electrons, and so on and so forth. So, if an element is in group 6, its outermost shell is going to have 6 valence electrons. So, similarity exists. So I've picked group 1 as an example, and the group 1 it has lithium, sodium, potassium. So I've picked the first 3 elements in group 1, and I'm going to write the electronic configuration and see what's similar in the electronic configuration. So lithium has 3 electrons, so the electronic configuration of lithium is going to be 1s2 and 2s1. Sodium, on the other hand, is 11 electrons, so its electronic configuration is going to be 1s2, 2s2, then 2p6 and 3s1. And potassium has 19 electrons, so its electronic configuration is going to be 1s2, 2s2, 2p6, then 3s2, then 3p would have 6, after which you would have 4s having just 1 electron. So if you look and compare the electronic configuration of elements in group 1, what you would notice is that the outermost shell has only one orbital, which is an s orbital, and it's going to have just 1 electron. So all group 1 elements have this similarity, which is that the outermost shell has an s orbital, and that s orbital is going to have just 1 electron. Now we can do a similar thing for group 2. I've picked 3 elements from group 2, and I'm going to try and write the electronic configuration. So beryllium has 4 electrons, so the electronic configuration for beryllium is going to be 1s2 and 2s2. For magnesium has 12 electrons, so the electronic configuration is going to be 1s2, 2s2, then 2p6 and 3s2. For calcium, the total number of electrons are 20, so the electronic configuration is 1s2, 2s2, followed by 2p6, then I would have 3s2, then 3p6, and after that I would have 4s2. Now if you look at the electronic configuration again, if you look at the outermost shell for all the 3 elements, then the outermost shell has an s orbital and it has 2 electrons. This outermost shell is also an s orbital, it has 2 electrons. And for calcium, it's the same, an s orbital having 2 electrons. So in all of these cases, the outermost shell of group 2 elements, so the outermost shell has an s orbital having 2 electrons in it. Now I've drawn this table here, and it's going to tell you the outer shell electronic configuration of all the groups. So as we have studied before, group 1 has an s subshell in its outermost shell, and it has 1 electron. Group 2 has an s subshell and it has 2 electrons. Transition metals also have an s subshell in the outermost shell, and they have 2 electrons in that. Any element in group 3 is going to have an outer shell having an s subshell and a p subshell. The s subshell has 2 electrons, the p subshell has 1 electron, and so on and so forth. So for example, if an element is in group 5, it's going to have, the outer shell is going to be containing an s subshell and a p subshell. The p subshell would have 3 electrons, the s subshell would have 2 electrons. And similarly, group 6 and group 7, the outer shell electronic configuration is given. So let's think of an element. Let's say I'm going to pick an element I'm going to pick an element in group 3. So if it's in group 3, so let's pick aluminium. And remember, it's in group 3, so the outer shell electronic configuration for aluminium should be an s subshell and a p subshell. The s would be having 2 electrons and the p subshell would have 1 electron. So let's try and write down the electronic configuration of aluminium with 13 electrons. So it's going to be 1s2, and then 2s2, then 2p6. So that's a total of 10 electrons. After that, it's going to be 3s2 and 3p1. 1. The 3p subshell would have only 1 electron. So if I underline the outer shell has an s subshell having 2 electrons and a p subshell having 1 electron, exactly as was shown over here in this table over here. It will have an s subshell having 2 electrons and a p subshell having 1 electron. Let's try and do this for any other element. Let's pick phosphorus, which has 15 electrons. So it has 15 electrons. It's in group 5. Now, based on the table, phosphorus's outer shell would have an s subshell and a p subshell having 3 electrons. S subshell which would be having 2 electrons. So let's try and write the electronic configuration of phosphorus. So it's going to be 1s2, 2s2, 2p6, and then there would be 3s2, and you are left with 3 electrons, so it's going to be 3s2, 3p3. So I'm going to underline the outer shell now. So this is the outer shell, the electronic configuration. There's an s subshell, 2 electrons, and a p subshell having 3 electrons, exactly as was shown in this table. So you can use this table to figure out the electronic configuration of any element. So let's do one more example. Let's take fluorine. Fluorine is in group 7, so it's in group 7. It has a total of 9 electrons. So the outer shell electronic configuration should be this thing. It should come up with an s subshell and a p subshell having 5 electrons. So I'm going to write the electronic configuration of 9 electrons. So it's going to be 1s2, and then it's going to be 2s2, and I'm left with 5 electrons, so it's going to be 2p5. So if I underline that, there's an s subshell and a p subshell having 5 electrons. So it's exactly what's shown in this table. So what you're going to do is you're going to if you have an element and you know what the group number is, so you don't actually have to write the electronic configuration to figure out what the outer shell electronic configuration is going to be. So any element in group 4 would have an outer shell electronic configuration which would be similar to this. The principal quantum number would be different, but the subshells and their electronic configuration would be exactly the same. Any element in group 2 would have an s in its outer shell having 2 electrons. So using this table, you can figure out the electronic configuration of any element and figure out the electronic configuration of the outer shell.